All right, so let's go ahead and get started on our next problem set. Anytime if you've ever heard somebody in the movies or in real life, they're talking about pulling G's or G forces in a jet, this is actually related to that concept. So centripetal acceleration happens whenever an object is moving in a curved path. It's the acceleration that helps basically bend it in the direction that it goes. And the formula is really not so bad. We have A for acceleration, a little c to show that it's centripetal. So that's a different type than what's called translational, which means in a straight line. And it comes from the velocity squared divided by the radius of what the big circle would be. So if you've ever noticed, if you're driving and you take a turn, if you're going on a great big wide arc and you're not driving very fast and you don't feel it. But if you have a very small radius or if you're driving really fast, then obviously you feel it a lot more when you make a turn. Now, there's some ambiguity as to exactly which force you're feeling. Technically, you're feeling the opposite, but it's at least close enough to get us the idea. The nice thing about it is that our units here and that are given to us are all in meters and seconds and combinations of those, which are our standard units. So we can plug in and get started. We'll worry about this part at the end, but for right now, I just want to find out what is the acceleration, and then we'll go from there. So that velocity is 584.87 meters per second. And then by our definition, that's going to get raised to the second power. Okay, and then we want to take whatever that number is, and we want to come back and divide it by 3276 meters. Now the units are going to do something a little bit funny here. If you notice on the top that it gets squared. So technically that part alone would give you meters squared, which is not part of what we usually want for acceleration. But if you notice we have meters on the bottom, then the meters and the meters squared will partially cancel. And then the seconds here also get squared by that exponent, and that's good because we want meters per second squared for normal accelerations. Okay, so it's going in the right direction. We're getting somewhere. So take the 584 squared up divided by the 3276 on the bottom, and you end up getting 104.41786 and blah 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 so on meters per second squared. So that's the acceleration in our typical units. What we want to do now to deal with this part where it's comparing to gravity is we actually just take this acceleration and we divide it by gravity, basically to see how many times bigger it is. We want to make that comparison there. So dividing gravity, this is not normally part of the question. This is a special question and terminology that goes with flying jet planes. What we get in this case about 10.65.